Alright, so here's the video that I promised for our Thanksgiving class, or for Wednesday of Thanksgiving week. I should apologize in advance. This is going to be the worst video ever because the pen that I usually use to make these is broken. So I tried to get creative. I was laying on the ground at my parents' house with my laptop upside down trying to use the camera. That didn't work. So what I'm going to do is just talk you through this video here and try my best to use the mouse to write, which is going to be really hard to do, but hopefully good enough that you can get something out of this. So anyways, the point of this video is I'm going to talk about the angle addition and subtraction formulas, which are these guys right here. There's 6 of them, 3 for angle addition, 3 for angle subtraction. I will provide them for you on any test, so you don't have to worry about memorizing these or anything. Really all I want you to get out of these is understanding how to use them. So that's what I'm going to demonstrate in this video. These are angle addition and angle subtraction. There's also 3 double angle formulas. That's these 2 down here and this one up here. Those are your double angles, because it figures out the sine of twice some angle or cosine of twice some angle and so forth. Then there's also the half angle formulas. So those are these guys. So they kind of break up into 3 different groups. Your angle addition and subtraction, which ends up being 7.2 in your text. I think that's true. And then your double angle and half angle formulas, which is 7.3 in your text. And we're going to do all of those just in one video here. So what kind of questions can you do with these? Well, this first question that I have here is kind of the basic type of question that you should expect to see. Maybe you're asked to figure out the tangent of pi over 12. And you're like, I don't know the tangent of pi over 12. That's not one of my memorized values up here on my unit circle. Right, I got pi over 6, but pi over 12 would be, I don't know, somewhere down here maybe. And that's not one of your memorized values on your unit circle. But you might recognize that pi over 12, I can get there by subtracting 2 angles that I do know stuff about in my unit circle. So you might recognize that pi over 12, oh, this is going to be painful, is equal to pi over 4, nope, pi over 3, divided by, nope, minus pi over 4. And if you come to that realization, then you can use this angle subtraction formula because you know all about pi over 3 and pi over 4, right? Those are 2 values that you have memorized off your unit circle, this guy here and this guy here. So if you can pick 2 angles that you know stuff about, then you can find information about an angle that's the difference of those 2 angles. And you're like, okay, fine, I guess I believe you that pi over 12 is pi over 3 minus pi over 4, but I, the student, wouldn't have seen that perhaps. Okay, that's fair, but maybe you could have converted this into degrees instead of radians. So instead of pi over 12 here, if you multiply by 180 over pi, maybe with the help of a calculator, I think what you'll see is that pi over 12 is 15 degrees. And maybe once you have it written in degrees, it's easier for you to figure out 2 angles that you can subtract to get 15. And you're like, how about 20 minus 5? Well, yeah, that is 15, but 20 degrees and 5 degrees aren't values that you know anything about on your unit circle, so that won't help you. It's true that you could use 20 and 5 to get to 15, but you don't know anything about 20 and 5, so it won't help you with that formula. So instead, maybe you choose, I don't know, 60 minus 45. That would work. That would be similar to what I have above. That's not the only choice that you have. You could also do 45 minus 30. That would also get you to 15 degrees. But maybe for the sake of an example, I'll just choose 60 and 45 here. And slowly, because it's a pain to write with a mouse, sort of demonstrate how you could use an angle subtraction formula to figure out the tangent of pi over 12. So first you'd recognize that pi over 12, aka 15 degrees, is pi over 3 minus pi over 4, aka 60 degrees minus 45 degrees. And once you come to that realization, you can figure out the tangent of pi over 12 by using this formula right here. And this one tells you that the tangent of the difference between 2 angles, A and B, if you know about A and B, is given by this formula over here. So if I just copy this exact formula that's written right here, but letting A be equal to pi over 3 and B being equal to pi over 4, what I can say is the tangent of, whoops, I don't know what that did, the tangent of, and maybe instead of pi over 12, it'll be easier to write 15 with my mouse. So I'll just write 15, and you can assume that I mean degrees here. That's equal to the tangent of, I'm going to run out of room really quickly because I can't write small with this mouse. What did I say, 60 minus 45? All right. faster I try to write, the more painful this becomes. And then you go up here, and you're like, oh, tangent of 60 minus 45. A is 60, B is 45, so you copy exactly what's written here. Tangent of 60 minus tangent of 45 divided by 1 plus the product of tangent of 60 and tangent of 45. So let's see if I can remember all that. Tangent 60. Maybe I'll pause this while I write that out so you don't have to watch me write. Now that I have that written out, all I have to do is fill in the values that I know, tangent of 60 and tangent of 45. Right, the reason I chose 60 and 45 to begin with is because I knew those values. And maybe you have those memorized because maybe you teach Math 112, or maybe you don't have those memorized, but you remember that tangent is sine over cosine. So tangent of 60 degrees would be sine of 60 degrees over cosine of 60 degrees. And you do some work and you simplify some fractions using what you know about this point up here and this x and y value. And I think what you figure out is that the tangent of 60 is equal to the square root of 3. And the tangent of 45 is equal to the number 1, which sort of makes sense because sine and cosine at 45 degrees here are both root 2 over 2. So their quotient's exactly 1. And then you divide that by 1 plus the product of those two numbers. But the square root of 3 times 1 is just the square root of 3. And we get here as our answer. And this is a perfectly acceptable answer. You can leave your answer just like this. In fact, I'm going to. It's worth pointing out that you can rationalize this. You could get rid of the square root of 3 if you wanted to. And you're like, oh, right, I remember that trick. Multiply the top and the bottom by root 3. That actually won't work here. Because if you multiply the bottom by root 3, it hits this 1 and this root 3. So you get rid of this root 3, but you create one over here. Just an FYI, not something I'm going to ask you to do. If you multiply the top and the bottom by 1 minus the square root of 3, it turns out that that makes things work out so that all the radicals in the denominator go away. But maybe for the sake of this example and the fact that I'm writing these with a touchpad on a laptop, we'll just call this a good answer and say that the tangent of pi over 12, aka 15 degrees, is this expression here. And if you wanted a numeric value, you could stick that into a calculator if you felt like it. But I don't feel like it. I'm going to leave it just like that. This next question asks me to do the exact same thing, except for use an angle addition formula. So what I did is I used an angle subtraction formula. I recognized that 60 minus 45 gave me 15. So you're like, what two numbers can you add up if I'm going to use an angle addition formula to get to 15? And I don't know, like 14 and 1 add to 15, sure. But then you'd have to figure out the tangent of 14 and the tangent of 1, and you don't know either of those values. So what two values off your unit circle add up to give you 15? That might give you some trouble. You might be like, I don't know any that make that work. Well, you got to think of negative values, right? If I take advantage of, I don't know, maybe this point right here, right? Yeah, it's 330 degrees, but it's also negative 30 degrees because those are coterminal. So I could add positive 45 and negative 30 in any order. It doesn't matter which way you do it. I could say tangent of 15 is equal to the tangent of, maybe I'll pause again while I write. Written all this, I'll unpause the video. We get that the tangent of 15 degrees is the same as the tangent of negative 30 plus 45, because negative 30 plus 45 gives you this 15 degrees. But now what we've managed to do is write this in a form that'll be conducive to using an angle addition formula, because I have one angle playing the role of A here is negative 30, and playing the role of B is 45. So I come up here and I grab my tangent angle addition formula, not the subtraction one that I just used, but the addition one right above it, which is almost the same as this one, except there's some negatives and positives switched. I'm going to take this formula, I'm going to plug in for A and B, negative 30 and positive 45, and then what we'll see is we come up with an expression, and maybe it looks just like this, or maybe it's just equivalent. I'll write it out for you. Alright, so what I did here, what I wrote, well, this was paused, took me way longer than it should, is I copied this exact formula here, my angle addition formula, except everywhere I saw an A, I changed it into negative 30 degrees. And everywhere I saw a B, I changed it into positive 45 degrees. And that gave me this expression right here. And the nice thing about this expression is I know all the values in here, because I know the tangent of negative 30 degrees and the tangent of 45 degrees. And maybe you know those immediately, or maybe you have to use the fact that tangent is sine over cosine, and what you have memorized off your unit circle. But the point is, because you know the x and y coordinates at those points, negative 30 degrees and positive 45 degrees, you can come up with all these values. And when you go plugging in those values, just like we did here, we'll get an expression. And I'll write those all down where this video is paused. All right, so I filled in these values. The tangent of negative 30 degrees. Turns out that's the negative of root 3 over 3. And the way I remember that is I remember this value and this value. One of them is the square root of 3 for the tangent, and one of them is root 3 over 3. And so the smaller of those two correspond with the one with the smaller slope. So this must be root 3 over 3. So I remember that this is tangent of root 3 over 3, and therefore this must be the negative of the square root of 3 over 3. But as I already mentioned, you can also get there by thinking about it as sine over cosine. So the y value divided by the x value. And I think you'll end up with this as the tangent of negative 30. So I throw that into my expression. The tangent of 45 degrees is still 1. I add those all together and I get this ugly looking fraction, which I kind of just like to leave as my final answer just because these are such a pain to write. But I feel like the good teacherly thing to do is to show how this answer is the same as this answer, because I'm figuring out the same thing, right? In either case, I'm finding the tangent of 15 degrees. So I better be getting the same thing no matter which formula I use. And it's not obvious at all how this is equal to this. But I think you can get there pretty quickly if we take this fraction here and you multiply the top and the bottom by 3. Right, you're not changing the value of the fraction. If we multiply a 3 on the top, it's got to hit both of these terms. When it hits the first term, it's going to cancel with the denominator. So I'll be left with just the negative of the square root of 3. And then when it hits this term, 1 times 3 just gives me 3. So I get negative root 3 plus 3 up on the top. And then the 3 that I multiply through in the denominator, this 3 times 1 gives me 3. And then the 3 times this term, well, the 3 and the 3 on the denominator will cancel, and I'll get here. So what I found is that this thing that I'm looking for, which I wrote as this way with fractions inside fractions, is actually equal to this. And I think maybe you can convince yourself that this is the same as this. The way you can do it is if you take this, what's written up here, and multiply the top and the bottom by the square root of 3. Right, the square root of 3 up top here would make this a 3, which ends up being this 3 right here. The square root of 3 times the negative 1 is negative square root of 3, which ends up being this term. The square root of 3 times the 1 is this root 3. And the square root of 3 times the square root of 3 is a 3, which is this 3 right here. So maybe I can just say, can you kind of see how this answer is the same as this answer? If you don't trust me, you could always plug those into a calculator, get a decimal approximation. And I think what you'll find is it's the same here and here. And that's probably good enough. I probably should just call this good, but since I already wrote it on the paper, I'm going to do one more of these to really beat this to death. I'm going to find the tangent of 15 degrees one more way, instead of using angle addition or subtraction. So instead of finding two angles that when I subtract them give me 15 degrees, or when I add them up give me 15 degrees, I'm going to find an angle so that when I cut it in half, it gives me 15 degrees. So what angle when you cut it in half is going to give you 15 degrees? Well, 30 degrees. And the nice thing about 30 degrees is I know all about 30 degrees based on my unit circle. So I take this half angle formula right here, and I say that the tangent of 15 degrees, which I can think of as 30 degrees divided by 2, because 30 divided by 2 is 15 degrees. So maybe I'll start out with an equal sign here. So what I'm saying is this tangent of 15 is also equal to the tangent of 30 over 2, because 30 over 2 is 15. But the nice thing about writing it in this form, 30 over 2, is now it fits into this formula. This is my half angle formula for tangent. It says the tangent of 30 over 2 is equal to, and I have my choice here. There's a couple of these formulas where you have a choice. Like over here, my cosine double angle formula, I have 3 choices. My tangent half angle formula, I have 2 choices. Whenever you have choices, it makes no difference. Use whichever one you want. You'll get the exact same answer either way. It doesn't matter at all. The reason you end up having choices is because sine and cosine are related. If we have the Pythagorean identity, right? If you changed this cosine into 1 minus sine squared, which maybe you can get that out of your Pythagorean identity, 1 minus sine squared is the same as 1 minus 2 of these sine squareds. Right? The reason this is equal to this is because of the Pythagorean identity. And you can do similar trig simplification to show that this formula is the same as this formula. But just grab whichever one you don't want. It doesn't matter. Maybe I'll take the top here. 1 minus cosine of x being 30, to make x over 2 15, divided by the sine of x. So the tangent of 15 degrees should be equal to, using this top version of this formula, 1 minus the cosine of 30 degrees. Maybe I can write this quick enough that I don't have to pause it. Nope, I'm going to pause it. Writing, so I had 1 minus cosine 30 divided by sine of 30. Again, that came from this formula with x being equal to 30. because if x is 30, x over 2 is 15. And the nice thing about cosine 30 and sine 30, again, is they're values I have memorized off my unit circle. So the cosine of 30 degrees is what, root 3 over 2? I don't know who I was asking that to. And the sine of 30 degrees is 1/2. And if I divide by multiplying by the reciprocal of the denominator, I kind of flip a 2 over 1 up top. And what I end up with here, I think when all the dust settles, maybe I'll leave it up to you to confirm this, is 2 minus the square root of 3. And you're like, oh, weird, I wouldn't have expected that to be the exact same as this. Yeah, frankly, neither would I. It's not obvious that these two are the same at all. I think the way you can show that they're the same is using that rationalization trick that I mentioned a minute ago, where you multiply the top and the bottom by 1 minus the square root of 3 here, or you multiply the top and the bottom by 3 minus the square root of 3 here. But maybe for the sake of the video, I can show you this via the power of Google, I guess. Let's just type these in and let it be my calculator. And this is going to be unfortunate if this is not correct, but I believe in these angle formulas so much that I can do this without even pausing the video. So the top expression I have, let's do this one, fine. I have the square root of 3, I wonder if Google will recognize that, minus 1, and then I want to divide that by 1 plus the square root of 3. Let's see if it kicks out a number. There we go, it gives me this number right here, 0.2679, blah, blah, blah. And then if I go down and take this expression, 2 minus the square root of 3, let's see what Google says. Google gives me this decimal. Look, it's the exact same thing. All right, that's not a coincidence. It's because 2 minus the square root of 3 is the exact same as this expression, which is the exact same as this expression, because no matter what, I'm figuring out the tangent of 15 degrees. And I can get there using angle subtraction, or angle addition, or half angle, or any other equivalent formula. I just wanted to give you experience with those three there. And frankly, that's probably the most common thing that you'll be doing. I mean, if I'm going to ask you a test question on these, the intro level stuff would be I'd ask you a question just like this. Figure out, if I want to make it hard, figure out the tangent of pi over 12. If I'm being nice, figure out the tangent of 15 degrees. But even if I say pi over 12, you can convert that to 15 degrees. And then what you have to recognize is, oh, 15, that's 60 minus 45. Or that's negative 30 plus 45. Or that's 30 divided by 2. And depending on which of those forms you choose, you use the correct formula. And then using what you know off your unit circle, you come up with an expression, and that's your answer. And that's the first thing that you'll be seeing on this homework that I want you to be able to do. Just figure out something, tangent, sine, cosine, it doesn't matter, of some angle. And that angle won't be a memorized value off your unit circle, but maybe it's the difference in two of them. So maybe it's, I don't know, 105 degrees. Like, how do I get to 105 degrees? That's somewhere in here. Oh, right, 60 plus 45. Or 135 minus 30. Or 210 divided by 2. Or, fill in the blank, whatever you want that'll get you to 105. And then depending on what you choose, use the appropriate formula. The second thing I want you to be able to do, which is a little bit harder, I think, but maybe not, I don't know, is you have an angle that's not specified. So up here, we were told the angle that we're talking about is 15 degrees. Down here, you're not told what the angle is. It's just some angle t. And this angle t is not one of the memorized values off your unit circle. All you know about this angle t is that its sine is equal to a third, and it's in the second quadrant. Right? So if it's in the second quadrant, that means it's between 90 and 180 degrees. If I'm going to deal in degrees, you can also do this in radians if you want. So 90 is less than t, which is less than 180 degrees. I thought this would be short enough that I could write it, but I might be mistaken. This is a pain to write. There we go. So this is my constraint on t just based on the fact that it's in the second quadrant. And then from there, I can figure out the sine of 2t. The sine of 2t, you might be like, how can I ever figure out anything about sine of 2t when I don't even know what t is equal to? That's true, but you do know the sine of t. And if you know the sine of t, really you know the cosine of t and the tangent of t, and I'll have to convince you of that later. And if you know all of those values, you can figure out the sine of 2t by coming up here and using your double angle formula. This says the sine of 2 times some angle xt, whatever letter you want to use, is 2 times the sine of t times the cosine of t. Right? I have that the sine of 2t is equal to 2 times the sine of t times the cosine of t. So if I just knew the sine of t and the cosine of t, I'd be done with this problem. I could multiply these three numbers together, 2 sine of t and cosine of t, and that'd be my answer. And the good news is I do know those things. One of them was given to me. The sine of t is a third. That's given to me in the problem. So this becomes 2 times 1/3 times the cosine of t. And you're like, how am I going to figure out the cosine of t? Well, if you know the sine of t, you can find the cosine of t. How do you want to do it? Well, there's lots of different ways you can do it. We learned two specifically in our class. One of them is think about the sine of t as the y value and the cosine of t as the x value. And x squared plus y squared has to equal 1. So if you know that the y is 1/3, you can solve for the x value. And based on the quadrant that it's in, maybe you can figure out that that x has to be negative. Another way you can do it, probably easier, is with Sohcahtoa. The problem with Sohcahtoa is Sohcahtoa doesn't account for the sign. And when I say the sign, I don't mean this sign. I mean the sign like negative or positive. So you could do this the harder way, but I think what you'll prefer to do is use Sohcahtoa. So draw this right triangle and put t wherever you want in the picture, and hope that doesn't happen. And then because this sine of t equals 1/3, that means the length of the opposite side to the hypotenuse has to be in the ratio 1 to 3. So you could write a 1 here and a 3 here. And if this is a 1 and this is a 3, you can solve for this side length. I think it ends up being 2 times the square root of 2, aka the square root of 8. And you can get there with a squared plus b squared equals c squared, aka the Pythagorean formula. And now that you have this right triangle, you can figure out anything you want. You want cosine of t? That's adjacent over hypotenuse. So you're like a square root of 8 over 3? No, but almost. It's almost root 8 over 3. The problem with this Sohcahtoa method is it doesn't track negatives and positives. Right? Because t is between 90 and 180, the y value, the sine value, has to be positive, and the x value, the cosine value, has to be negative. So even when you draw this picture, you have to remember that instead of putting root 8 over 3 here, it's the negative of the square root of 8 over 3, which I can write hopefully very slowly. And then, man, that's annoying. That ends up being your answer. And yeah, I guess you shouldn't leave it like that. You should simplify. So you multiply across. 3 times 3 is 9. 2 times the square root of 8. You could write that as 2 root 8. You could also write it as 4 root 2. You can write that however you want. I'm not super concerned. Maybe I'll leave it as 2 times the square root of 8 with that negative sign divided by 9 and call that good. But I'll make the note that you could also write the numerator here as negative 4 times the square root of 2. And that's because the square root of 8 is the square root of 4 times the square root of 2. And the square root of 4 is another 2. Anyways, this answer ends up being this. And just like you can find the sine of 2t, you can also find the sine of t over 2. And the way you could find the sine of t over 2 is instead of using a double angle formula, use a half angle formula. So you come up here and you're like the sine of t over 2 equals plus or minus the square root of 1 minus cosine of t over 2. Plus or minus is weird. Okay, so what's going on with these half angle formulas? Each one, or that's not each one, sine and cosine, you see this plus or minus out in front. That doesn't mean that there's two answers. It means there's two possible answers and you have to choose which one. How am I going to choose which one? You got to think about which quadrant you're in. So if t is between 90 and 180, then t over 2, half of t, is between 45, half of 90, and 90, which I'm eventually going to write, which I would be writing much quicker if I had a pen that worked. Sorry that I don't. Essentially what I'm doing is I'm taking this constraint that I had on t and thinking about what it means if t is between 90 and 180. What's that tell me about half of t? Well, half of t is in between half of this number and half of this number. It's in between 45 and 90. What I'm saying is half of t, t over 2, this thing right here is in my first quadrant. When I'm in the first quadrant, the sign of something in my first quadrant is positive. So when I go up here and look at my formulas, I don't want a plus or minus here, I just want the plus. Because t over 2 is in the first quadrant, and the sign of something in the first quadrant is always positive. So the hardest of these to use are the half angle formulas, and you just have to be careful about the sign, not SIN, but SIGN, whether this is positive or negative. Once you get that it's positive, you can write this is just the positive, what was it, square root of, see I don't even have these memorized, that's why I'm going to always provide these to you. The square root of, ooh, that's nice looking, 1 minus cosine of t over 2. So if I just knew the cosine of t, I'd essentially be done with this problem. Well, the good news is I do know the cosine of t. I already figured it out in part A in this problem, right? Cosine of t, that was this value. You're like, it's negative. Is it supposed to be negative? Yeah, it is negative because the t is between 90 and 180. And cosine, when you're between 90 and 180, is negative. So part of this is negative. That doesn't mean the entire thing's negative. The entire thing's positive because sine of t over 2 is positive. But don't worry about the fact that in place of cosine of t right here, I'm going to write negative square root of 8 over 3. So what I'm going to get here for my answer is the square root of 1 minus negative square root of 8 over 3. 1 minus a negative, that's just the same as positive. Root 8 divided by 3. And that entire thing, remember that's just the numerator of this fraction, gets divided by 2. And this is the right answer, what's written there, but typically I ask you to simplify so you don't have fractions inside of a fraction. So you think about this as 2 over 1 down in the denominator here, and you flip it upside down. So you kind of have 1/2 times all this stuff. So you get the square root of 1/2, which times this 1 just gives me 1/2, plus, and I don't know, maybe I'll leave it as root 8 over 6, even though I could simplify that more. Stop. There we go. And call that good for my final answer. When I said I could simplify that more, that's because the square root of 8 is 2 times the square root of 2. So I could cancel out that 2 and then a 2 from the denominator and call this 1/2 plus root 2 over 3, all underneath the radical. But I'm not going to bother because I don't want to write this again because it's so slow to write with using a trackpad or whatever this thing's called on my laptop. So I'm going to end this video here. Sorry for the technical difficulties. Hopefully this is useful to you. I'm going to send this in an email along with the blank version of this and maybe these PDF solutions in case anybody couldn't suffer through these formulas. But really the big takeaway is just, hey, here's a bunch of formulas. Now you know 2 different ways to use them. And when I say 2 different ways, the first way is if I just ask you for some trig function, sine, cosine, or tangent, of some angle. And that angle is not on the unit circle, but that angle is the sum, difference, half, or double of some angle that's on the unit circle. And you pick the formula you use. And the second context where you can use this is where you're given information about some angle t. Even if t isn't an angle you know on your unit circle, you're given information like its sine equals 1/3. And you're asked to figure out something like twice that angle or half that angle or something to that effect. So those are the 2 types of questions you'll see on this homework, and those are the 2 types of questions that I think would be fair game on a quiz. So if you can do these, you're in pretty good shape. I'm going to call this good here. Hope you guys have a good Thanksgiving. I'll be checking in on email if anyone has any questions on anything. Otherwise, I'll see you when we get back next week.